Hi everyone, these are the calculus section 9.3 notes called separable equations. And the best way to do this is to just start with an example. So I'm going to ask you to solve the differential equation. Solve the differential equation means if I give you a derivative equation, can you get its antiderivative? And I know you know how to antiderive, but sometimes two sets of variables will be mixed together, x's and y's. And you can't antiderive that until you separate the x's from the y's. Hence, separable equations is the title. So for example, dy over dx, okay, and you should all know that y prime means dy over dx. Just note that the derivative, there are several notations for derivative, and one of them is y prime and another one is dy over dx. These two mean the same thing. Equals x squared over y squared. And so what we're going to do is we're going to get x's and y's on the same side. So x is on one side, y is on the other. So I'm going to cross multiply, and when I cross multiply, okay, I'm going to get y squared dy like that equals x squared dx. And so I've got all the y's on the left and I've got all the x's on the right. And what I'm going to do is I'm going to antiderive both sides. I'm literally going to put in an integral symbol on both sides. And so I begin. What's the antiderivative of y squared? It is y to the third over 3 equals, what's the antiderivative of x squared? It's x to the third over 3. I'm going to add a plus c on this side. I mean, technically we should be adding a plus c on the left and a plus c on the right, and they don't have to be the same. But if I had a constant here and a constant here, I could subtract this constant over to this side and end up with another constant. So you can just put the plus c on one side, and it's normally best to put it with the x. And then all you have to do is solve for y. So I'm going to multiply everything by a 3 like this and get y to the third power equals x cubed plus 3c. And then I'm going to cube root both sides like so. So y will equal the cube root of x cubed plus 3c. And this is my answer. So if the original was the derivative, this is its antiderivative. Let's do another one. If I tell you that dy over dx equals 6x squared over 2y plus cosine y. Remember, your goal is to get the y's on the left and the x's on the right. So I'm going to go ahead and cross multiply, okay? And I'm going to get 2y plus cosine y in parentheses dy, okay, that one. And then I'm going to get 6x squared dx. So after this is where I antiderive both sides. I take the integral of both sides. So what's the antiderivative of 2y? It is y squared. Plus, what's the antiderivative of cosine y? It is sine y. Equals, what's the antiderivative of 6x squared? It's x cubed, and then it'll be 6 over 3, which is 2, plus c. And then I have to solve for y, except the issue is it's literally impossible. Y squared plus sine y, to combine or factor out a y, that's not possible here. So guess what? This is as close to the antiderivative as we are going to get. That would be the answer to this, because it is impossible to solve for y. And so remember in section 9.2, back to problem number 1, you know, we were given a dy over dx equals whatever over whatever, and that was this is called the differential equation. And we were able to come up with a slope field, remember, with a bunch of, you know, tangent lines, whatever the pattern was. This, when you antiderive both sides, gives you the particular solution. Like if you go to a certain point, they would have to give you an initial condition. And you connect, like you get the actual curve. This is the curve. The differential equation gives you all the possible tangent lines. Okay, let's do another. Let's see. Number 3. Y prime equals x squared y. Okay, and it's the same set of directions. Solve the differential equation. That means get y equals. If this is y prime, antiderive. Now I can't antiderive this because of the two variables on one side. And remember, y prime is the same as dy over dx. You definitely want to make sure that you replace your y prime with its equivalent, an equivalent expression, which is dy over dx, because you're going to want to separate the variables. You're going to want to get the x's on one side and the y's on the other, and y prime is not going to help you. So what I'm going to do is I'm going to cross multiply again, and I'm going to get dy times 1 is just dy equals, I have x squared y dx, and I'm almost there. I just have to make sure I can get this y onto the left. So I'll divide both sides by y, and I will get dy. This is dy times 1 over y, right? dy over y is the same as dy times 1 over I equals x squared dx. And now I'm ready to antiderive, although I don't like the way this looks. I want to put the 1 over y in front of the dy equals x squared dx. And now I will antiderive both sides. So what's the antiderivative of 1 over y? It is ln absolute value of y equals, yes, it's important to have the absolute value. Then we have the antiderivative of x squared, which is x to the third over 3. Don't forget the plus c. And now we have to solve for y. So, question, how do you get y out of a log? Remember, there's a little tiny base e here. I'm going to convert the log into exponential form. If you forgot, I'm about to tell you. You go base raised to this entire exponent, okay, equals argument, which is the absolute value of y. Now it's almost solved for. The absolute value of y has to just be y. So how do you get rid of the absolute value bars around y? Remember, absolute value means anything inside of the absolute value can be a positive or a negative. The bars convert it into positive. So if I remove the absolute value bars, that means I have to put a plus or a minus in front of this term. And so we are done. I want to show you something. Note, this is a perfectly awesome answer. Sometimes on the AP exam, I see them split this into e to the c power times e to the x cubed over 3 power. Why do you get to do that? Because when you multiply like bases, you add exponents, which turns into this. So I'm going in reverse. So either or is a perfectly great answer. Okay. All right, I'm going to do one more problem. And this time, I'm going to give you an initial condition. So the directions are find the solution of the differential equation that satisfies the given initial condition. All right, so here's the equation. dy over dx equals cosine x over y, and the initial condition is y of 0 equals positive 2. So first things first, let's begin by separating the variables. So I'm going to cross multiply. I'm going to get y dy equals cosine x dx. Okay, I have the y's on the left, the x's on the right. I'm ready to antiderive both sides. So I put in those integral signs and I begin. All right, the antiderivative of y is y squared over 2. The antiderivative of cosine, is sine x. Don't forget the plus c. Now in the other 3 problems we did, we weren't able to find a plus c because we didn't have an initial condition. But now, before I solve for y, I'm going to go ahead and plug in the initial condition. So when x is 0 and y is 2, I get, what is this? 4 over 2 is 2. The sine of 0 is 0. So it looks like c is equal to 2. So then I resume. I take this answer that I had and I put c in there. Y squared over 2 equals sine of x plus 2. But now I have to solve for y, okay? Because it said find the solution. That means y equals. All right, so I think I'll begin by multiplying both sides by 2 and get y squared equals 2 sine x plus 4. I'm just distributing. And then I'm going to square root both sides. And when I square root, I can't forget my plus or minus in front of the rad. And now, here's what I can't do. I can't leave my answer as 2 different answers. This is 2 answers. It's the positive rad and it's the negative rad. So which one do I choose? Because it says find the one and only solution. When you have an initial condition, you can only have one solution, not 2. So you got to look at this point. This point is 0, 2, right? When you write it as a point instead of function notation. Look at the y value. What kind of y value do you have? Do you have a positive or a negative? It says positive 2. So that tells you that you will choose the positive. So the final answer is y equals, y has to be positive. Y cannot equal anything negative. Rad 2 sine x plus 4. So if the point, the initial condition was like 0, something negative, I would have chosen the negative rad answer. So, and that's how you do separable equations. And that, you guys, is the end of Calculus AB. Congratulations.